Welcome to the 24 Hours of PaaS evolution of the data platform. We're excited you could join us today for one Chaves session, Swimming in the Data Lake. This 24 Hours of PaaS event consists of 24 consecutive live webcasts delivered by expert speakers from the PaaS community. The session will be recorded and posted online after the event. To access any on-demand sessions, please visit 24hoursofpaas.com for all session links. My name is Stad. I'm a DBA from the Netherlands. I have a few introductory slides before I hand over the reins to Warner. If you require technical assistance, please type your question into the question pane located on the right side of your screen and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get into the Q&A portion of the session, I'll read your questions aloud to the speaker. You are able to zoom in on the presentation content by using the zoom button located on the top of your presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will appear in your browser. I'd like to take a moment to thank our presenting sponsors, Microsoft, Amazon Web Services, Redgate, and Hortonworks. Hortonworks develops, distributes, and supports the only 100% open source distribution of Apache Hadoop, explicitly architected, built, and tested for enterprise-grade deployments. It's the only Hadoop-based platform available on both Linux and Windows. In addition, I'd like to thank the supporting sponsors for this event, Hewlett-Packard Enterprise, SQL Sentry, and SanDisk. The staging of the 24 Hours of PaaS would not be possible without their generous support, and they are the reason this event is available free of charge. Make sure you explore everything else PaaS has on offer for data professionals. You can join local user groups around the world, special interest groups, find free online resources through our Learning Center, and read up on the latest community news in the Connector newsletter. This session is presented by Warner Chaves. He's a DBA and consultant for 10 years, previously on L3 DBA at HB in Costa Rica, now a principal consultant at Pitian in Ottawa, Ontario. He's a SQL Server Microsoft Certified Master and MVP. He's got a blog, SQLturbo.com, which I visited today. It has got some nice content in there. So, from this point on, I'd like to give the reins to Warner.
Sounds good, Sander. Can you hear me well?
Yeah, perfectly.
Alright, so let's get started here with swimming in the data lake. Thanks everybody for joining here today at the 24 Hours of PaaS. Really excited to be showing this new material of a service that is right now in preview in Azure. So let's go over the agenda for today. First of all, the goal is we're going to do an overview of what the Azure Data Lake service is. So we're going to introduce the service and some of the fundamental concepts to understand the service and what is the value proposition of the service. Why should we care about it, and also a little bit of why as a DBA you should care about it. We're going to then talk about the Azure Data Lake Store, which is the storage component of the Azure Data Lake service. Then we're going to talk about the Azure Data Lake Analytics, which is the querying component of the Data Lake service. We're going to talk about U-SQL, which is the SQL language kind of dialect that was developed for Azure Data Lake. And I think as DBAs, you're going to find this piece really interesting. We're going to jump into the demo right after we're done with all the theory. We're just going to focus on the demos. We're going to do an exploration through the portal to see what the portal experience is right now once you get into the preview. And we're also going to do a quick demo of what the experience is if you're working from Visual Studio and you hook up your Visual Studio to your Azure account and you download the Azure Data Lake components for Visual Studio. And after that, we'll do a recap and then our Q&A. All right. So what is Data Lake and why should we care about it? Well, Data Lake is a cloud platform as a service offering for big data. So main thing to understand, first of all, is that it's PaaS. It's a PaaS offering, right? So it means that management is minimized. So we don't have to manage, obviously we don't have to manage any hardware because it's in Azure. We don't have to manage operating systems. In this case, we don't even have to manage any sort of execution engine, right? So let's do a comparison. Let's say, for example, your company is getting interested in a big data project. And what are some of the things they could do? So they could go in on premises and buy a bunch of hardware and install, let's say, for example, Hadoop, literally on that hardware. And then if they need to scale up for some sort of analytics they're doing, they need to go out and buy a new machine and put it there and rack it, and eventually they'll run the job again and it might go faster this time, right? So not really attractive proposition as far as developing this type of solutions on premises. Now let's think about doing this in the cloud. One option would be to just deploy Hadoop yourself in the cloud. At that point you're managing the VMs and you're managing Hadoop. Another option is to use a managed Hadoop service, just like HD Insight. So at this point, you are not managing the OS, you're not managing the hardware, but you are responsible for Hadoop. And as long as that cluster is up, you are paying for that cluster. So Data Lake Analytics and the Data Lake service in general is one step up in abstraction from that. So in this case, we don't even have to worry about the Hadoop cluster itself. If I want to run a query, I submit a job to Azure and I say, hey, this is my Data Lake Analytics account. That analytics account is hooked up to a data store and it just runs the job and I get charged for the job and that's it. I don't have to provision a cluster, I don't have to pay for compute I'm not using, etc., etc. It's very, very attractive and can fit very well into an organization's larger data architecture. Why? Because we can think of, well, where do I want my relational data? Well, we probably want it in a relational database. If we're here at the PaaS event, I'm going to guess that most of us are very experienced with SQL Server, so you'll probably put it in SQL Server, or you'll put it in Azure SQL DB, or nowadays even in Azure SQL Data Warehouse. Now, for the unstructured data, or just data that you don't really have a use to put in a database right now, but you don't want to get rid of it, Data Lake is a great fit because it's separate. It separates storage from the analytics. So if I bring in a bunch of data that I just don't know what I'm going to do with it yet, I only pay for storage. And we know that storage in the cloud is, pretty dirt cheap. So it's a very attractive proposition in that way. It can receive any type of file. You don't have to specify a schema. I can use my data lake store to store CSVs. I could use it to store any sort of text type of file. I could use it to store even binary files if I wanted to, and then down the line maybe, I don't know, maybe we could do some image type of analysis on some image files that I have on Data Lake Store, right? And then the other thing that is very attractive if you already have an investment in Azure especially is that it can interface really easily with the other analytical service like machine learning or Power BI, and it has also some built-in integrations with Azure SQL DB, for example, SQL Data Warehouse, and we'll go a little bit more detail into that as we go through the slides, okay? One thing to keep in mind, and I have to give a shout out here to my colleague Phil Lavery at Pragmatic Works. We were having a conversation about this data lake when he did the SQL Saturday here in Ottawa, and he said, well, I just hope that people realize that it's supposed to be a data lake and not a data landfill, right? Because we say, you can store anything. You don't have to specify schema. You don't have to, there's no limits in the sizes of a file. There's no limits in the size of the storage that you can put in Azure Data Lake. So how do we try to keep it to actually being a data lake and not turning into the data landfill, right? So these are the do's and don'ts. Just because we can store anything, it doesn't mean that we should. there are still, other pieces of the puzzle, like I mentioned, that handle data differently. So if we're talking about, OLTP, if somebody's developing a system like that, you don't want to put that in Azure Data Lake. It makes no sense to put it there. You got to put it in relational, either Azure SQL DB or SQL Server in a VM. If we're going to talk about a data warehouse project, so we're talking about large consumption of data, but most of it is structured, then Azure SQL Data Warehouse is a great option, right? If we're talking about just storing a bunch of JSON documents, but we need them for quick interactive querying, then DocumentDB would be a good option in Azure, or any other equivalent type of NoSQL solution. For example, if you wanted to deploy a Cassandra solution in Azure. So just because you can put everything in it does not mean that you should, right? That's my main point, right? We want to see unstructured data or data that we don't know how we want to analyze it right now, but we want to just keep it for now and eventually do analysis on it. That's really the big value of data that we can put there in the data lake. So don't think that, just because we can put anything on it and it can grow to any size doesn't mean that it won't need a DBA, it won't need an administrator, and it will need some sort of direction and guidance, right? So IT governance, control, procedures are still important, right? You want to have a nice logical structure to your data lake store. You want to make sure that the proper people have permissions to put data there, the proper people have permissions to create the analytics jobs and all these. And we'll go into more detail about what are the components of the service that enable us to control this type of thing and again, not end up with a data landfill instead of a data lake, all right? So the data lake service, like I said, is composed of two different parts. One is purely the storage piece, and one is purely the analytics piece. Now this is very powerful as well because it means that we can incur costs on storage without incurring costs in analytics, right? So if I have, let's say, 5 terabytes of storage, and I only need them for a report that runs once every month at the end of the month, then it means all throughout the month I'm only going to pay for the storage. And then if I run that report, and that report runs for, let's say, 4 hours doing something on a specific amount of analytic units, and we'll go into that a little bit later on, then I only pay for that execution of the job. And then I pay for the rest of the month, I only paid for storage, which is very cheap in the grand scheme of things in Azure. So this is very, very attractive, for example, compared to something else like, let's say, a service like Redshift in AWS, where compute is coupled with storage. So when you deploy a new node, you're deploying cores, you're deploying RAM, and you're deploying the storage that comes with the node as well, right? So in this case, it's not like that. It's completely separate. Storage can live permanently without doing any analytics, and then the analytics are only fired up when we need them on the spot, and then we stop, and we don't get charged for anything else. So the data store, and think about this as well. So Azure already has storage, right? We have the blob storage, and it's been existing in Azure for many, many years at this point. So there's differences, though, here. So it's like an evolution of the blob storage in Azure because it has no limits on the object size, and there's no limits on the data lake size either. Whereas I believe there's a size limit on the blob storage account. It's a big limit, is in the terabyte range. But let's say, if you're going over that limit, you're storing at the petabyte range, it will basically overflow your regular blob storage account. So this new entity of a data lake data store was created. And as well as that, the data lake store, the storage underneath it is optimized for parallel read scans and low latency writes. So typical type of behavior or characteristics that we want in a big data solution, right? It can ingest data quickly, and it can read a lot of it fast, right? Scans, optimized for scans. It's not optimized for random reads here and there like an OLTP database would be, okay? The data analytics piece, the most interesting piece, besides, like I said, you only get charged if you run the job or not, is really the U-SQL piece of the equation. Because really what they did with U-SQL, and we'll go through the demos, and many of you guys will be surprised and you'll be like, wow, I didn't realize this data lake service would seem so familiar to me. and you might actually get excited that you're going to start playing around with big data really easily, because they really aimed to decrease the friction of a SQL developer or a SQL DBA to start working with big data and help with either conversions, transformations, or analytics purely, right? And like I said, we'll see it on the demo, but the U-SQL is very, very similar to T-SQL and allows you to get up and running, being productive really, really fast, right? And like I said, you create a script, you submit it as a job, and then you can scale it up or down. You can say, hey, this job usually it takes longer, and if I run it at a certain amount of the time, so I'm just going to bump up the amount of compute power that I want for it because I need it to be done faster today, and so on, right? So the service is dynamic in that sense. And we'll go into details now in the behavior and the billing of how it works with data store, and then we'll do the same for the data analytics, right? So like I said, the data lake store is just an evolution of the regular blob storage, but really it has nothing fancy or no like really complicated concepts for you guys as DBAs and storage, people that work with storage and data every day. It's just a file system. That's pretty much all it is. You get, when you create your data lake store account, you get a root folder, and then you make folders and you put files on them, and that's pretty much all it is. The characteristics of the file system is what makes it special, right? Because it's already replicated, so you don't have to worry about keeping the backup copies. The service already does that. The system also has some APIs, so it can work with any Hadoop type of tools that will support HDFS, and the system will also take care of distributing your files and splitting them into multiple machines if the files are really big enough. So all that is handled automatically. You don't have to worry about it, right? So even, for example, and this is something that I haven't tested, but I did read on the documentation that it's possible, is that you can even bring up an HT Insight cluster and then point that cluster to a data lake store, because as far as the Hadoop APIs are concerned, it just reads the data lake store like if it was any other type of Hadoop file system. So that's pretty interesting as well, because it means, if there's something that you couldn't do for some reason with U-SQL and just through submitting a job with U-SQL, nothing's stopping you from rolling up your sleeves and using a full-blown Hadoop to do the analytics for your data that you have in the data lake store, okay? Something very important as well as we work in the cloud is security, of course. So the data lake store can integrate with Azure AD, and it supports role-based security. So as we all know, that's usually the best practice, the easiest way to manage, just how we do it with SQL Server. You create your roles, you give the permissions to the roles, and then you assign people to those roles, right? Right now we have a couple of different levels of permissions like owner, contributor, reader, or user access administrator, and those can be provided easily to through the portal right now. Now the ACLs right now are limited. Remember, the service is in preview, so right now it's only allowed in the full file system. So if you give a permission on the data lake store, right now it's like you give me either read, but then you gave me read on everything, or you give me read and write, but then I have read and write on everything. But this is for the preview. I looked into it, and yes, the full-blown ACLs for particular folders and particular files will be available by the time the service goes to general availability. Now I don't really know exactly when that will be, but I have to say the preview has advanced quite a bit, so I wouldn't be surprised if it's in the next few months that this is just open now for full-on general availability. Right now it's on public preview. If you go on the portal and sign up, it'll send you an email basically, and then after a few weeks you'll probably get access to your account. Okay. So the data lake store ecosystem. So what are some of the tools that we can use to work with data lake store? So if we're interested in moving data, so obviously we want to copy data in, We can do it with Azure Data Factory, and that would be probably the full-blown platform as a service way of doing things. So you would just move data with Azure Data Factory. If you guys are not familiar, Azure Data Factory is a sort of SSIS in the cloud. It works kind of similar with the concept of, just extract, transform, load, and it supports many of the different Azure services, right? So Azure Data Factory is full support for Data Lake. You could do it with PowerShell because there's also commandlets that work with Data Lake, so you can definitely do it that way. The portal has some functionality to create the folders, to upload files, etc. Because it's also HDFS compatible, you can use something like Scoop, which if you're familiar with the Hadoop tools, Scoop allows ingestion of data into Hadoop clusters. You could do it with something like Storm. Storm, if it's an event processing system that it's from the Apache Foundation. It's also used in Hadoop. You could do it with Azure Event Hub. So for example, if you're reading a bunch of, let's say, like an IoT data and you're getting it all on your Event Hub, then from that Event Hub, you could just put it all on a Data Lake sync. Basically just target a Data Lake file to put it there. And then there's also the Azure Import-Export service. I don't know if you guys are familiar with this, but that's basically where you literally ship a hard drive or like a storage container to an Azure data center, and Microsoft takes care of copying everything over for you. So I've never done that, but I know it's available because it was there in the documentation. Once you need to process, then of course you can do use the Azure Data Lake Analytics, which is the one that we're going to dive into in the second piece of the presentation. You can use HD Insight, like I said. HD Insight can hook up to the Data Lake store, so you can use that if you need other type of Hadoop tools that are not available just through U-SQL. So you can do your map reduce, so type of running just like batch type of jobs against the Data Lake store. You could do HBase, for example, or you can do Storm, which is again the event processing type of thing, right? Now, if you are thinking of visualization, so it's all good. I was able to run an analytics job. I have the answers right now, but I mean, I can't just, give a CSV to my managers and tell them, hey, here's your answers, right? That's kind of crude. Usually most of us will use some sort of BI tool or BI report, right? So a very easy thing to do, and thanks to the integrations that Data Lake Store and Data Lake Analytics has, is that you can just move the results of the job into a relational structure, right? So you could say, for example, that 6 terabytes, let's say, as an example, 6 terabytes that I have in Data Lake Store, I run an analytics job once a month, and the result of this analytics job is just 10,000 rows that give me a bunch of aggregation over billions and billions of records. And then I can just take those 10,000 rows and put them in an Azure SQL DB, for example. And once it's in Azure SQL DB, well, you can pretty much read it from any BI tool on the planet, right? The other option as well is Power BI, just because it fits so easily into the full-blown cloud ecosystem of not having to manage anything, right? So with Power BI, you can connect to your Data Lake store directly and pull information from the files there, and that will make it even easier, right? Or as well, you can use Power BI with any of the relational products and just put the results of a job into the relational and then get Power BI to read off of that. So very, very simple to do it that way. So let's see, let's talk about the billing model. So like I said, the storage part is pretty cheap. So data stored is about 4 cents gigabyte per month. So if we're talking about 4 cents, Data Lake transactions is 0.07, so that's 7 cents per million transactions per month, okay? And the transactions, the way it's defined is a unit of 128 kilobyte or less, right? So if you make a very small type of write, or like write really small files, that's kind of wasting a little bit the cost, and that's going to increase your cost because it's going to be billed as a unit of 128 even if you don't reach that exact number or not, okay? So like the slides say over there, if you do 1 kilobyte, you're going to bill as one transaction, even though you know the unit is 128 KB. But if you go over it, then the service will basically split it, right? So if you upload a file that's, let's say, 1 megabyte, then the service is going to split the 1 meg file into 128 KB chunks, and you're going to be billed transaction-wise. You're going to be billed by how many transactions it would be to write that file. So in this case, it would probably be around 9 or 10 transactions, right? So again, the guidance here, or the really best practice is, you know, try to make your files always bigger than 128 KB, so you're not losing that type of capability from the service. If you make them all super small, then you're going to be paying transactions when you could have just accumulated a little bit more data and then get more data uploaded to the cloud with the exact same price. Okay. Okay. So now that we've talked about the Data Lake Store, let's talk about the Data Lake Analytics. This is the partner service, right? So this is the platform as a service offering for processing big data. Again, I explained why it's full PaaS. There is no operating system to manage. There is not even a Hadoop cluster to manage. It's literally just submitting jobs, creating scripts, submitting jobs, and working with whatever data you have on the data store, right? So this is the partner service to the Data Lake Store, and it's really designed for scale out and parallelism. So if you have a really small data set, you might not think that it's really that fast. It takes a while to spin up the resources to actually do all the work. So if you're just going to process, like, let's say 1 gig of data, then it could be, for example, it's faster to process that on a SQL server, right? So you have to really think about scale and the type of the amount of data that is worth it to split it and to actually process with a big data type of solution, right? So if you only, for example, and this is something that has happened to us as well when we're helping our clients and developing proof of concepts, is that somebody runs a test and the test only, you know, they loaded 500 megs to the cloud and they ran a test of Data Lake Analytics versus a test on running Hadoop on their own laptop, and then their own laptop was faster. It's like, well, yes, I understand that, but that's because you're not really taking into account that it takes a cost to consume all those resources in the cloud, and it's not built for 500 megs. In 500 megs, you're not going to get any difference, but if you process 500 gigs between your laptop and the Data Lake Analytics, then Data Lake Analytics is going to win that competition, right? And then finally, like I said, it's designed to be easy to pick up for SQL professionals, and we'll go into details on that because I mentioned U-SQL, but there's also a concept I'm going to touch on further later on called the U-SQL catalog that is going to look even more familiar to all the DBAs here in this session, okay? So let's go into detail on the Data Lake Analytics. First of all, running analytics, the whole experience focuses literally just on running jobs. It does not focus on infrastructure at all, to the point where the system scales the jobs using what is called an analytics unit. Basically, an analytics unit, you can think of it as, you could say it's a machine. So if you say, you know, I want 4 analytic units, that means the Azure is going to use 4 machines to analyze your data. But it's not defined that way. I just find it's easier when you think about it in those terms, but literally what the documentation says is you get assigned a compute container. So we don't really know exactly what a compute container is. And really the whole point, and the people that I've spoken to this at Microsoft say, well, first of all, they didn't want to define exactly what it is because they could be doing improvements on the service all the time. And, you know, let's say the compute container gets a faster clock speed, then suddenly all the jobs will be faster. They would still be one analytic unit, right? So the best way to really find this out is just to test. So if you have your significant data set in the cloud and you run a test with a couple of analytic units, just take notice of how much time it took, and then you can bump it up and run another job and see how much it takes, and really just find that amount of analytic units that satisfies your service levels, right? So what do I mean by that? For example, if I have a job that will take 4 hours on 4 analytic units, but it can run overnight, then there's really no issue there. If that's the 4 analytic units is enough, then to be done with my SLA, then I can just pick 4 analytic units, right? Whereas if this same analysis at some point or some times of the month, we need to get that report out in less of that time, then we can bump up the analytic units, right? As long as we have to find that sweet spot between good performance and satisfying our service levels, right? If our service level gets tighter, then we can increase the AUs. But if we're already satisfying our service levels, then there's no need to increase the AUs, because I mean, if you add AUs, you're going to be paying more, right? This is the knob here where we turn on the volume on how much power we want. Visual Studio has some tooling, and we'll see it on the demo. Obviously, this is a big boon for people that are familiar with Visual Studio. Many of us here, DBAs, do a lot of work with Visual Studio with SQL Server data tools, right? So we use it a lot for SSIS, package authoring. We use it a lot for SSRS reports. We use it a lot for cubes on analysis services, or even for database type projects and creating DAC packs or backpacks. So if you're familiar with Visual Studio, don't worry. It's the same Visual Studio type of experience with the Solution Explorer. You can add your U-SQL scripts. You can edit them in Visual Studio. It has some nice syntax highlighting and so on. So that's really cool. I mentioned as well, the analytics can be integrated with other Azure services. So you can, for example, pull data from Azure SQL DB. You could pull from Azure SQL Data Warehouse, or even from just regular blob storage. Something else as well, I didn't add it now that I notice here on the slide, but you can also pull from a full-blown SQL server. So if you have a full SQL server running in Azure that is running as a VM, you can as well open that up. So as long as you have your firewall for your VM open to Azure services, and obviously you have the credentials to be able to connect to it, then you can also pull data from SQL Server running inside a VM. So again, this is very attractive for us as DBAs if we know that we need to do an analytics job, but we need to bring in some data from another source. Then we don't have to literally come up with another type of job that will copy that data every time before we run our analytics job. No, we can actually connect to it through the analytics job on the fly. So that's really powerful as well. So let's talk about U-SQL. Like I said, this is really the value proposition for me as far as how Data Lake Analytics was created, because it mixes SQL semantics and the power of C#. So if there's something that you want to do that you can't get done just with SQL, you can still have the same concept of reading records and writing to tables, but then you can do this, you can add at any time the power of C# to do more complex things. So for example, if I had, let's say I'm saving images, right? So how do you really work with images with SQL semantics? It doesn't really make a lot of sense. But if, for example, I can write an extractor is the component that reads information from the files in the data lake store. I could write an extractor that says, hey, for this image on C#, strip the headers, the headers that will say where the image was taken, at what time, and the longitude and the latitude, and what type of camera you were using, all those things that we know the modern cameras are all tracking. Well, we could write on C# something that will strip the headers off of the images, and then that create a record, and then that record put it in either a table inside Data Lake Store, or put it inside Azure SQL DB, or put it inside Azure SQL DW. Very, very powerful stuff that you can do then without, again, having to spin up any type of infrastructure, right? Forget about spinning up servers. This is the really, really cool thing about all these platform as a service offerings. We don't have to be spinning up servers and thinking about shutting them down and all that kind of stuff. U-SQL can work with unstructured data, like I said, by applying schema on read. So that applies to my image example. So images, by definition, they don't really have a schema, right? They're unstructured. But if I can read an image and I understand it and I can parse it in binary with a C# and extract that header information, then suddenly I can apply a schema on an image, right? So that's the powerful piece as well. I can on the fly read any type of unstructured data and apply a schema on it. If it's easy, like a table separated value, like a tab separated value file, or a comma separated value file, well, U-SQL already includes those really trivial kind of extractors. So if all you have is a bunch of CSVs, you're just consuming them, you don't really know what you're going to do with them, but they're just putting them in the Data Lake store, and then eventually down the line somebody says, hey, let's try to do some analytics on those CSVs. Well, then U-SQL already has support for those types of files, right? So it does come in with support with some sort of the more common type of just raw text files. It runs on a distributed parallel runtime, so we'll show on the demo as well some really cool visualizations. When you run a job, it shows you what type of work it's doing. So it does run distributed, and that's the way it was built. So again, it will split the work for the query into multiple machines based on how many analytic units you give to the job, right? And then the data types are C# types, and they are .NET objects as well. So if you have a string and you need to write some sort of transformation on it, you can go into the C# code and then use all the methods that are part of the string class, for example, to get done whatever it is that you need to do. So here's an example of U-SQL. So we're declaring, let's say, a string there. So that string is really the path. Remember that, like I said, Data Lake Store is literally just a file. Just think of it as one giant drive that is attached to some cloud computer. That's all it is, right? So even though we know it's actually that distributed file system is probably composed of a bunch of different computers and everything, for us it just literally looks like one giant drive, and that's all it is. So there's no need to really get much more complicated than that. So in this case, we're declaring that first string. That's going to be, an output and the path for file. And then we're just going to declare another one. It's just going to say the same path, but add the underscore agg.csv, and that's all it does, okay? So then we create that variable there that says search log, and it says extract, and that's where we define the schema. And it says from the samples data search log, so that's the other, the path where we're going to find those files. And this here, we're just targeting one file, but we can use wildcards. So we could be reading, 1,000 search logs, not just one search log. And this is, as you guys can see, they're using extractors.tsv. So like I said, there's different type of extractors already built into the service for the more common type of structure that people put on text files, right? Usually tab separated values or comma separated values, right? So we're extracting from this file into this variable. So we'll put the schema on the file, we'll put it in the variable, then we're going to run an actual select on that variable that has all this data. So there you see select the region, sum duration, group by region. This is like as familiar to SQL as you can get for anybody that works with SQL Server day in and day out. So really easy to understand. And then when we do the output, we literally just take the variable and then we output it from that variable that got assigned the results of the select to the path. And then this instruction literally just goes in, takes, okay, I'll get that table variable, I have to put the results in this other variable, and I'm going to order it by this, and I'm going to use this format using, you see there, outputters.csv. So instead of reading in a tab separated value, which is the original format, we're going to output it as a comma separated value, right? So very, very similar syntax to what we're used to working with T-SQL. Very easy to read, very easy to understand, okay? Now there's another concept that it's very interesting. I didn't realize until I started really playing around with the service and doing some proof of concepts. I thought the U-SQL piece was just the language and that's it, but it actually, the Data Lake store comes with something called the U-SQL catalog, and this is literally like a database inside the Data Lake store. So inside the U-SQL catalog, you can create tables. The tables can have indexes. They can have stats, just like any other table. So if you have a certain amount of, let's say, you have some files that you already know that you're going to want to have them schematized in a particular way, then you can put those files, move them into a table inside your U-SQL catalog, and then all the other scripts that you write can refer to that table by name, right? So if down the line, for some reason, you need to change the logic that reads the files and puts them in the relational format, you only need to go back to the script where you read the files and put it in the table, because all the other scripts can refer to the table inside the U-SQL catalog. So this is something that's really cool. It can have views, so you can create, for example, this one that's also very interesting. If you don't want to materialize a table, but you always want to have the same definition of a table, let's say like a schema-only table, you can create a view, and the view can point to files in the Data Lake store. So you're not really saving the data twice. All you're doing is that your script refer to the view, then the view will always go and read all the files when you run your job, right? So that's another possibility that you can do. You can develop functions in C#. You can have store procedures as well. So if you have a set of code that you just want to have live inside the U-SQL catalog, you can do that, and then you can just run a script that calls the store procedure, just how we do it with databases as well. And you can even have user-defined operators or aggregators and extractors. All that stuff has to be developed in C#. So this U-SQL catalog, like I said, it's the U-SQL piece, the querying piece, very familiar for anybody that writes T-SQL. The U-SQL catalog database piece, very familiar for anybody that is used to just regular old SQL Server database storage. All right, and the service, of course, comes with components to manage it. So the users that you can give permissions, the data sources that you can attach to the jobs. The jobs are basically what does that U-SQL that we want to run. And then, like I explained, the U-SQL catalog, it can be used to structure data and code, and then you can share all those with U-SQL scripts, right? So you have two people working with, let's say, the same type of table. You could create the table in the U-SQL catalog, and then the entire team only has to target those tables, and it will make development much more easier. All right, and the analytics billing model, the analytics unit, like I mentioned, that compute type of unit, you pay by the minute, and then you have a fixed rate for any type of job that completes, right? So this case is 2.5 cents per job, and 1.7 cents per minute of an analytics unit. And right now, by default, the service will give you up to 50 analytic units and up to 3 jobs that you can run concurrently. But if you give a call to support, they can bump up those limits for you as well. All right, so let's jump into the demos. I'm going to go into the portal and show you guys what it looks like on the portal, and then I'll show you guys the Visual Studio experience. Okay, so let me go into my cloud machine. And right now, I am here on my Azure portal. Easiest way to get to it, you want to browse, and then from browse you can pick Data Lake Analytics, and that takes you into the screen of the main blade of Data Lake Analytics, and here you can do a couple of interesting things. For example, I can see previous jobs that I've run, so I'm going to click on that. So here's my history of the jobs that I've run and how long each one of them took, and it keeps some pretty detailed info for each one. So I can click on this latest one that I run, and if it was still running, it would give me a progress here telling me if it's queued or if it's running right now. It tells me what the input was for this particular analytics job. It tells me what the output was. In this case, it was a log file with responses from a search log. And it also gives you what will be the kind of like the execution plan of the analytics job. So you have a step that does an extract and then a step that does an aggregate. It uses two vertices. Two vertices here is like two tasks basically. This one, the aggregation was done with one task. We read 15K of data, and we wrote in the end just 39 bytes for this of data here, and ended up being in text 314 bytes. So again, you get like a view of an execution plan here in the portal, which I think is pretty cool. You can also go in and see exactly what is it that you did during that job execution. If you just go in to see the script, so you guys can see here the script basically took a table that was already in my U-SQL catalog and ran a where clause on it, and then it put the results of that where clause in that log file, and that's all I did, right? So very complete right now, at least the way that you can display the jobs. If you have to submit a job, you can do that here through the portal as well. So I can go new job. And once I have the new job screen, I can write my U-SQL here, I can give the job a name, and I can submit it as well. There's two things that I can touch here. I can set a priority for the job. So lower numbers means higher priority. If I only have one job at a time, then obviously it's no problem. But if you, let's say we can only have 3 concurrent jobs and we submit 10 jobs, then the 3 with the highest priority will go first. And then after that, the other 7 will get ordered based on their priority number, okay? And then parallelism is the amount of, like I said, analytic units that we want to use, which you want to think of as the amount of, let's say, computers that you're going to throw at the problem. And we can scale from 1 all the way to 20 in the portal right now, okay? So that's pretty much the portal experience. Let's go into Visual Studio. Visual Studio, so first, there's if you go here to File and you go to New, once you've installed the Data Lake components, you guys can see here I have a U-SQL type of project, and the U-SQL node comes with different projects. I can do a U-SQL project, a class library. So like I said, you can bring in C# components into your U-SQL jobs, right? So you could create a class library that does something with, again, let's say images, and then share that class library with different U-SQL projects. So that's pretty cool. Unit test project for U-SQL, a sample application for U-SQL, and a test sample for U-SQL, giving some examples of how you want to build your your analytics jobs. Okay, so that's the project flavors that you get. Here's an example of syntax highlighting. So here I am creating a database in the U-SQL catalog if it doesn't exist. I'm dropping the function. If it exists, then I'm creating the function. The function basically is just returns a table. Here's the schema and reads it through the text extractor, and I'm telling it that the limiter on the text extractor in this case is just going to be white space for this weblog file, okay? So this view, every time I run it, is going to go find this weblog file and it's going to return me that type of table variable, okay? In this case, what we do is for the actual permanent storage inside the U-SQL catalog, here's a create table statement, so it should look very, very familiar to all of you guys. We are basically saying, hey, I want to create this this table, and I want to have a clustered index on the year. I want to have it partitioned by year, and that's pretty much it. If you guys can see, then we specify the select, so it will take the schema of this select and put it into this table and index it in this way. So clustered means the same as in SQL Server. It means that it's going to order the rows in this way. And partition by means the same as SQL Server, except here it has support for hash partitioning. So it'll take the year, hash it, and it'll put it inside a partition that fits for that year. This create table as construct also exists on Azure SQL Data Warehouse, I believe. Okay, so these take several minutes to run. I already ran one earlier today, so I can just show you guys real quick how it looks here on Visual Studio. So you can have the different steps. If you mouse over, you get all the details from execution, kind of like how we do on the execution plans of Management Studio as well. So very easy to get up and running for a DBA as well. And you can see it by different things, which is something that I thought it was kind of cool. I wish Management Studio would do that for SQL Server too. So here it just displays progress. So if it was a long job, it would be starting to turn green. But if you want to see, for example, the colors based on how much data was read, or you can see the colors based on how much data was written, so we can see both read a similar amount of data, or we can see the colors based on how long each step took. So we can see that this step took longer than this step, really easy, just looking at the colors, and so on, right? It'll save the log that you can see here as well, and it'll give you some diagnostics too. So for example, here, I'm going to zoom in real quick, and you guys can see it says 2 data lake analytic units were over allocated. So I ran this with a parallel AU of 4, and the file is not that big, it's just a demo. So the service didn't even use 4 machines, the service just used 2. So it's telling me, hey, you're over allocating for 2, so it kind of gives you a hint. Next time, don't ask me for 4 because I didn't really use 4. Just ask me for 2. So I think that's really cool as well. It helps you tune automatically your own jobs. All right. So recap: Data Lake itself is a big data platform as a service offering. Just because you can store anything doesn't mean you should. We want a data lake, not a data landfill. The service is split into the Data Lake Store piece and the Data Lake Analytics piece. The U-SQL jobs, I hope the little bits of U-SQL that you guys saw today kind of like demonstrated to you that is really nothing to be afraid of. If somebody's starting to get interested in Azure and big data and a data lake conversation, you guys should not be afraid of it at all. Very easy for a DBA to pick up and work with. Each one is built separately, so very powerful as well. If you want to keep all the data but you only run analytics on very few times of the month, then you'll be able to get all the savings from that as opposed to having to create a cluster and keep it provisioned the entire time. And then finally, this data lake service really fits easily into a modern organization data architecture because it fills the gap of having to do a fully managed, roll up your sleeves on your own, manage everything type of big data service. So you don't have to worry about all those pieces. All you have to worry about is how you're going to store your data and how you're going to run the analytics. So like I said, for SQL professionals, data professionals in general, most of us are very proficient with the SQL language. Really easy to just go and like literally start up and running. Okay, so at this point, let's head over to the questions.
Yeah, we've got a couple of questions. Some people have left to ask the question, so I'll concentrate on the other ones first. Scott Cameron asked if do analytic units provide performance that scales linearly?
So ideally, yes, but some of the tasks are not linear by nature, right? So if you're just consuming data, and let's say your data is evenly distributed, how you guys saw, for example, I can distribute, when I create tables, I can specify partitions and distributions and so on. So if everything's evenly distributed, then you would say yes, but I mean, there's some things that might not scale linearly necessarily, right? Like an aggregation on one partition, and one partition just happens to be bigger than all the others. That's probably not going to scale linearly just by the nature of the work. But the tools are there. I guess that's the cool part about it, is that you can use those tools that I show you, the visualizations, to see what the service is doing with the data, and then just tune from there and realize if it's worth it to add more analytic units, or if it's better to go back and optimize your schema or optimize your SQL, and instead of just adding more power, kind of like brute force style. Okay.
Okay. Anna Dolavienko asked if U-SQL is based on Hive.
The underlining of U-SQL is not public, so I can't really tell if it's based on Hive or not. I can ask and see what people tell me in the, the corridors. But as far as I know, it's not public knowledge if it's based on Hive or not under the covers.
Oh, I see someone answered it's based on scope. Lucian Xu asked how the unstructured data is stored in the data lake.
Oh, it's just literally files. So whatever way the file is, a data lake is not going to manipulate it or do anything to it. It's just going to copy the files, and it's going to do the regular replication that is done with an HDFS file system. So there is no, there's no type of manipulation that the service will do to your files, and there is nothing that you need to manipulate before putting the file into the store as well. So neither in neither direction there's any manipulation needed or there's any manipulation done. It's literally, like I said, like having a giant drive and you just throw files at it, and that's all.
Okay. Azagapan Agun Chalam, I hope I said that right, asked if there an API to manage the scheduling of jobs based on ADL analytics.
Yeah, so that's a good question, and actually there's a bunch of different answers to that. So the service doesn't have a scheduler built in, but the service for sure has not only the REST API, it also has PowerShell commandlets, right? So anything that can run PowerShell on schedule can run a data analytics job. So that means, for example, if you want to use the built-in Azure scheduler service, you can do that. That also means that if you, for example, have a VM in the cloud that is always running and you want to schedule the job there through a Windows scheduler or run a PowerShell, oh, you can do that as well, right? The other way you can do it is completely in the full-blown PaaS offering, is to just do it as a part of a Azure Data Factory pipeline, right? And just have an Azure Data Factory pipeline that's literally just calling U-SQL scripts, right? And then you set up the schedule through Azure Data Factory. So the answer is there is ways, of course, but there is no scheduler built in the system. The idea is that Azure already has ways to schedule activities, and you can leverage those, either Azure Data Factory or the built-in Azure scheduler.
Okay. I think we're almost out of time, because the next session is going to start in about a minute. I think we're going to wrap up, and then the questions will be sent to you, and you can answer everybody.
Yeah, absolutely.
Make sure you stay tuned for our next session. SQL Server 2016 just works faster. Performance improvements in database core engine with Robert Dorr.